Hello students, my name is Alok Semwal and in today's lecture I am going to discuss about various analytical performance characteristics used in method validation. So as I discussed earlier, there are various typical analytical performance characteristics which are used in method validation. These characteristics include specificity, which is also known as selectivity, linearity, range, accuracy, precision, detection limit, quantitation limit, robustness, and system suitability testing. First one is specificity. Specificity denotes the extent to which a diagnostic test is specific for a particular condition or sample. By the use of few specific methods, we can estimate the actual value of the analyte in presence of several other components which may be present in any sample. Various types of identification tests, assay, and impurity tests are performed in the following type of determination method. By the use of specificity, it is possible to determine whether any sample contains impurities or not. Next analytical performance characteristic is linearity. The term linearity refers to the property of scaling. Linearity is a type of mathematical relationship that can be graphically represented as a straight line graph. Linearity of an analytical procedure is its ability to obtain test results which are directly proportional to the concentration of analyte in the sample. Linearity should be evaluated by visual inspection of a plot of signals as a function of analyte concentration or content. For example, linear graph between concentration versus absorbance is obtained by ultraviolet spectroscopic method, and the graph can be used for the determination of concentration of unknown sample. For the establishment of linearity, a minimum of 5 concentrations are recommended. Next performance characteristic is range. The range of an analytical method is the interval between the upper and lower limits that have been demonstrated to be determined with accuracy, precision, and linearity. For example, upper and lower concentrations of analyte in the sample. This range will be the concentration range in which the linearity test is done. In the analytical method validation, specified range is generally derived from linearity studies, and it depends on the intended application of the procedure. Next characteristic is accuracy. As the name suggests, accuracy is the degree of agreement of test results with the true value, or the closeness of the results obtained by the procedure to the true value. Accuracy should be established across the specified range of any intended analytical procedure. For the determination of accuracy, it is recommended to have minimum of 9 determinations over a minimum of 3 concentrations levels fulfilling the specified range limits. Accuracy is mandatory in case of various assay procedures and in the quantitation of impurities. Next one is precision. Precision of a method is the degree of agreement among individual test results when the procedure is applied repeatedly to multiple sampling from a homogeneous lot. Precision denotes reproducibility or repeatability of results. It is usually expressed as the standard deviation or relative standard deviation of any series of measurements. Precision can be performed by assaying sufficient number of aliquots of homogeneous lot, and after that calculating statically valid estimates of standard deviation or relative standard deviation. Next is detection limit. Detection limit of an individual analytical procedure is the lowest amount of analyte in a sample which can be detected but not necessarily quantitated under the stated experimental conditions. So the detection limit is a crucial factor in determining whether a molecule can be identified and quantified within the acceptable limits. Here, quantification is not possible in all the methods using detection limit. Determination of detection limit is based on either visual examination or signal to noise ratio. Next is quantitation limit. Quantitation limit or quantification limit denotes the lowest amount of analyte in a sample that can be reliably measured by a particular measurement procedure by following precision and accuracy parameters. All analytical techniques have their limitations on estimating analyte concentrations, and there are various representations of the quantitation limit like LOD and LOQ. LOD stands for limit of detection, while LOQ stands for limit of quantitation. Limit of detection is defined as the lowest quantity of the analyte substance that produces a signal at least 3 times the average noise level of the detector. Here is the noise level, and this peak A denotes limit of detection. Limit of quantitation is the lowest concentration of the analyte that can not only be detected but can be quantified within defined limits of certainty. Usually, limit of detection and limit of quantitation refer to limits associated with 95% probability of obtaining a correct result. Next parameter is signal to noise ratio. Signal to noise ratio defines the ratio of an desired analytical signal to the mean noise level for a given sample. It can be used to determine the influence of noise level on the relative deviation of a measurement. For example, in this diagram, following peaks are denoting the unnecessary signal, which denotes noise. Next terms are robustness and ruggedness. The terms robustness and ruggedness refers to the ability of an analytical method to remain unaffected by small variations in the method parameters. Ruggedness of an analytical method is the degree of reproducibility of test results obtained by the analysis of the same sample under a variety of conditions such as different laboratories, different analysts, different instruments, different lots of reagent, different assay temperatures, different days, etc. Robustness denotes the ability to withstand or overcome adverse conditions or rigorous testing. Robustness denotes property of an analytical procedure to remain unaffected till a defined limit because of careful variations in the method parameters and provides an indication of its reliability during normal uses. The evaluation of robustness should be considered during the development phase and depends on the type of procedure under study. Next characteristic is system suitability testing. System suitability testing is generally used in laboratories to ensure that the complete analytical system, which include instrument, reagents, columns, and analysts, are suitable for the intended application or not. System suitability testing is an integral part of the various analytical procedures. Following table denotes recommended validation characteristic of the various types of tests under analytical method validation. These includes accuracy, precision, specificity, detection limit, quantitation limit, linearity, and range. In the following table, minus symbol signifies that the characteristic is not normally evaluated, while plus denotes that the characteristic is normally evaluated. 1 is used in cases where reproducibility has been performed, but intermediate precision is not needed. Number 2 denotes lack of specificity of one analytical procedure, which could be compensated by other supporting analytical procedure. Number 3 may be needed in some cases. Following are the references of this presentation. Thank you.